Hello, one and all. Welcome to Hacker Channel. Before delve into our today session, let's have a quick discussion about what do we exactly mean by the word model in networking. Like a recipe to make a pizza or a plan to build a robot. When performing a certain task between nodes in a network, there is a certain number of layers. Each one has its own specifications. The two communicating nodes should follow it one by one in order to get that certain task done. This set of specifications or protocols is called a model. The two most popular types of models are the OSI model and the TCP/IP model. In this video, we will discuss the OSI model. OSI stands for Open System Interconnection. It consists of 7 layers. Each layer represents a specific set of functionalities, allowing for a modular and hierarchical approach to network design. This model serves as a foundation for understanding and implementing communication protocols, making it a fundamental concept in networking and system architecture. In this video, we will explore each layer of the OSI model and delve into its significance in the world of computer networking. The 7 layers that consisting the OSI model are the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and lastly, the physical layer. The order of those layers is dependent on whether you are the sender or receiver. If you are sending a message, it will start from the application layer, then going down, and the opposite in case you are receiving a message. The application layer will be your last station. Let's start with the application layer. The application layer is an interface between the network and the application. In case of sending a message, the application layer will do the job of take the data from the app and put it in a form that the other lower layers of the OSI can understand it and work with it. But in case of receiving a message, the process will be reversed. Application layer will take the data from the lower layer, then put it in an understandable format for the app in the receiver device to represent it. Now let's move to the protocols used in this layer. HTTP and HTTPS. HTTP refers to Hypertext Transfer Protocol, while HTTPS refers to Hypertext Transfer Protocol Secure. As we know, they are both used in web browsers such as Google Chrome, Mozilla Firefox, Safari, and others to load and display web pages. Another protocol is the SMTP, which refers to Simple Mail Transfer Protocol. From its name, we know that it is used for sending and receiving email messages. Another protocol is POP3. It refers to Post Office Protocol version 3. POP3 is an email retrieval protocol which used for allowing clients to download email from the server, then delete this email from the server after it had been downloaded in the client device. Last protocol we will discuss in this layer is the FTP, which refers to File Transfer Protocol. FTP used for transferring files between clients and servers in a network, allowing users to upload and download it. Now let's move to the presentation layer. Presentation layer is an intermediate between the application layer and the session layer. By using ASCII system or EBCDIC system or Unicode system, the presentation layer will do the job of encode the message, then give it to the session layer if we are in a sending process, or decode it and deliver it to the application layer in case that we are receiving a message. In case that the sender and the receiver are using 2 different coding systems, presentation layer will do the job of changing the message from one coding system to another. It also have the function of encryption the message when sending it to ensure its security and decryption it when receiving, through using cryptographic protocols such as SSL, which stands for Secure Socket Layer, and TLS, which stands for Transport Layer Security. Next station we have is the session layer. The session layer has nothing to do with the message itself, and also it relays on the lower layers. In simple words, it uses the lower layers to do a certain function or check that they are really working. And its functions are all about establishing the session, managing the session, and make sure that the message is received and also received in the right form. Now let's delve more on those functions and see what the session layer exactly do. The session layer has those functions. Firstly, the function of session establishment, which is indeed done by the transport layer, but as we said, the session layer is an interface to the lower layers. It uses them to do a certain function. When the session is established, now there is a way or a road between device A and device B, which allow them to send and receive information. Another function for the session layer is the token management. Token management is the mechanism that control and organize the priority of conversation during the communication between devices. This way, we ensure that collision and disruption during the process will not happen. Another function for the session layer is the dialogue control. The session layer involves managing the flow of information between two devices during a communication session. It ensures that data exchange follows a structured and coordinated pattern, allowing both parties to take turns in sending and receiving information. This helps in maintaining the integrity and order of the communication process. The session layer also have the function of synchronization, which means it put a marker or a checkpoint every time after sending a certain amount of data. The benefit of synchronization is to make the recovery fast and easy if a collision or disruption was happened. Next layer we have is the transport layer. To make it clear, we should put in mind that the actual delivery of data is the physical layer responsibility. But the transport layer is responsible for end-to-end communication between devices. End-to-end communication means that to make sure the message is delivered and in the correct form. If not, then the transport layer will fix the error or resent the message if it didn't received. As we said in the last video, in case that we are using user datagram protocol, the message will be sent one and only one time, even if it didn't received. Unlike if the protocol was the TCP, then the message will be sent again and again until it received. Beside the end-to-end communication and reliable delivery of data, transport layer have other functions such as data segmentation. From its name, data segmentation means to separate the data into small pieces. So if an error was happened, we should retransmit that certain piece that wasn't delivered, not the entire message, which will make the transmission more reliable. And also, it will enhance the speed, especially if the network has limitations on packet size or bandwidth. The speed is measured in megabyte per second. As example, when we say the internet speed is 45 megabytes per second, we mean that the transport layer of the network between your device and the server will transfer a 45 megabyte of segments with each second. Also, one of the transport layer functions is to place the segment header on the message. The segment header contains many components. The most important one, and the one that we will discuss, is the port. Different applications and services are placed in so many groups. Each one of those groups has its own identifier that we call it the port. Accordingly to what application you're using as a sender or receiver, there is a port will lead the message to that application in the receiver's device and acts like a door to that room. As example, web pages that using HTTP are in port 80 and emails that using SMTP are in port 25 and many other ports for other apps. In the transport layer, the port of the source and destination will be added to the segments of the message to make it hit the right application in the receiver's device. Next station in sending process will be the network layer. The main function for the network layer is the logical addressing of data. Each device in the world have an address, which we call it the IP address. In the network layer, the address of the sender and the receiver will be placed on the message, which will tell the message its destination and where it should go. After we determine the address of the sender and the receiver, now it's time to choose the best and fastest path to deliver this message. We call this process routing of data. Before we move to the protocols used in the network layer, we should mention that the message in the network layer, and after adding the IP addresses and some other structures, is called the data packet. Now let's take a look at the protocols used in the network layer. The Internet Protocol, which is responsible for addressing and routing packets across networks, as we discussed. Another protocol in this layer is the ICMP, which refers to Internet Control Message Protocol. The Internet Protocol is the main protocol in the network layer, but this protocol and the others we will mention can work beside the Internet Protocol. The ICMP job is to send messages that called control messages, to check the network stability and report errors in the network. Another protocol is the IGMP, which refers to Internet Group Management Protocol. When we want to send the same message to a big number of nodes in a network, instead of repeat sending the same message again and again for each node individually, we can put them together in a group and make them share the same IP address. We call this group the multicast group. The IGMP deal with those kind of groups. Its job is to tell the router which nodes showed interesting in that certain message. Router will deliver that message to them simultaneously as a group, and also just to that interested group, not to the entire network. ARP and RARP. They are two different protocols which do the reverse job of each other. ARP refers to Address Resolution Protocol, and RARP refers to Reverse Address Resolution Protocol. Before we know the functions of those two protocols, we should mention that to send a message, the sender's and receiver's IP address and MAC address must be known. Now, we know the IP address and MAC address of the sender, and also the IP address of the receiver, but what we miss is the MAC address of the receiver. Here comes the ARP function. It will send a message to that IP address and ask it about its MAC address. The function of the reverse, ARP, is exactly the opposite. It is used in the booting system. The boot knows its MAC address, but misses its IP address. So it will send a message to the server and ask it about its IP address using the RARP. Next layer we have in the OSI model is the data link layer. It's called the link layer because it connects the software layers, which are the upper layers, with the hardware layer, which is the physical layer. For this reason, it divided into two layers, the LLC, which refers to the logical link control, and it contributes to the upper layers, which are the software layers, and the MAC layer, which refers to media access control, and it contributes to the physical layer. The logical link layer is responsible for complete the error detection and flow control of the message that is received from the upper layers in the process of sending the message. On the other hand, the MAC layer is also responsible for error detection when data is received from the physical layer, using the FCS, which is referred to frame check sequence. FCS is a value that will be calculated in the sending process accordingly to a specific algorithm. Then, it will be added to the trailer of the message. This value will be checked in the receiving process and see if it's the same to accept it or not the same to reject it. In addition to the FCS at the trailer, the MAC addresses will be added at the header of the message in the framing process. We call this structure the data frame. Now let's discuss the protocols used in this layer. The Ethernet protocol, which is the most common used protocol in the data link layer. Its job is to add the MAC addresses to the message and also detect if there is an error in the message, as we mentioned previously. Another protocol can work beside the Ethernet is the PPP, which refers to point-to-point protocol. Its job is to encapsulate all the protocols and other structures that have been added to the data segment and make them as a single union structure that is ready to be delivered to the next layer, which is the physical layer. Physical layer is the fundamental layer of the OSI model. Without it, not any of the upper layers will work, and the data transmission will never occur. Now let's discuss how the physical layer will send the data frame to the other physical layer at the receiver device. Firstly, the physical layer will transfer the data frame into bits, zeros and ones. Then it will transfer those bits into analog signals. There is many different kinds of the analog signals, but the most common used one is the electromagnetic waves. The electromagnetic waves could be electrical signals through an electrical cable, or light pulses through an optic cable, or radio waves through the air. As we said, there is other types of the analog signals rather than the electromagnetic, such as sound, vibrations, and pneumatics. After that, the physical layer will isolate those signals from one another, and finally send our message directly to the receiver's device. Now let's talk about some specifications that is used in this layer. We can divide them into three groups. Firstly, the wired group, which using specifications such as the Ethernet, which widely used in the LAN network, the USB or Universal Serial Bus, the HDMI or High Definition Multimedia Interface, and the DSL or the Digital Subscriber Line, which used in the telephone lines. Secondly, the radio waves group, which use specifications like Wi-Fi, Bluetooth, LTE, or long-term evolution, and many other specifications. Thirdly, the optical group. In this group, we got specifications like SONET, or Synchronization Optical Networking, which will ensure synchronization of data, and also allows multiple devices and different data to share the same physical fiber optic cable, which will increase the speed and reduce the cost. SDH, or Synchronization Digital Hierarchy, which use the same standards as SONET, and it is widely used in Europe. Hopefully, the message will reach its destination successfully, and the same process will repeat reversely. After the message is delivered at the physical layer of the receiver, it will convert it from binary into data frame. Then it will pass it to the data link layer. The data link layer will check for the MAC address and the FCS and confirm they are both right, then pass the message to the network layer. Network layer will check for the IP address, confirm this is the right destination, then deliver it to the transport layer. Transport layer will check for the destination port, determine which application or web server will be used at the application layer. Also, it will combine the data segments together and make them as a single unit. After that, the session layer will send an acknowledgement to the sender's session layer and tell it that its message has been delivered successfully, and now it's time to cut it off. After that, session layer will deliver the message to the presentation layer, which will decrypt and decode it. Then finally pass it to the application layer, which will represent it. So that was all for today. Don't forget to like the video, share it, and subscribe in the channel. Thanks for watching, and see you in the next video.